Welcome back to Algebra with Miss Swartz. Today we're going to be looking at the Chapter 3 quiz review in hopes to get you ready for the quiz, which is on Tuesday. We're just going to go over the questions that you had for homework on Friday, and you can check to make sure that you did them right, make sure you understand all the concepts. So let's get started here. For the first two, we have to determine whether the relation is a function, and we need to explain why it is or is not. So if we look at number one, remember, okay, a function is a relation that for each input has exactly one output. So if I look at all my inputs here, I have 5 different inputs there, and each of them have exactly one output. So this number one would in fact be a function because each input has its own output. Okay. Number two, if I look at number two, I would have to look at my inputs, -10, -8, -6, -8, -10. In this case, this is not a function because with -8 and -10, it has more than one output. So okay, so this is something you definitely need to know for tomorrow's quiz. What is a function? Then we have to look at domain and range. So we skip number 4, but we are going to look at 3 and 5. So domain, remember, is all possible input values. Range is all possible output values. So you would need to know those definitions. When we have, like number 3, just ordered pairs, we can just list our x values, which would be our inputs, and list our y values, which would be our outputs for our domain and range. So our x values here are 0, 1, 2, 3, and 4, because this is 0, -5, 1, -3, 2, -1, 3, 1, and 4, -3. So our range is all those y values, so -5, -3, -1, 1, and we already have -3 listed, so we don't have to list it twice. So it's a little bit easier when we have those ordered pairs. You could just list out your ordered pairs, list the x values as the domain, the y values as the range. But when we have a continuous graph like number 5, we have to list all possible values. So when it's continuous, we have to even think about, okay, what about in between, in this case 3 and 2. We have to include all those because the graph includes all those. So we have to include everything. And we're talking about our domain, our input, our x values, so everything along the x-axis that is in the graph. So the smallest that we see is -3. The largest that we see is 3. So x, if we put x in the middle, it has to be less than -3, but greater than, less than +3, but greater than -3. Our range now is all of our y values. So if we look at this, as tall as it goes to as low as it goes. So the lowest is at -1. So y has to be greater than -1, but less than 3. Because it goes up to 3 here. This is probably the toughest for most students. So if you're having trouble with those, Try to practice. There's other practice problems in your textbook. See if you can find other practice problems. The quizzes might have a couple of them, so just practice a lot. Okay, the next part is determining whether the graph, table, or equation represents a linear or nonlinear function and explain. So we have to know what those look like on a graph, in an equation, and in a table. So with our graph, pretty simple, we're just looking for a line. Since this is a line, this would be a linear function because we see a line in the picture. Linear, that's what we're looking for, is a straight line. In the chart, we're looking for a constant rate of change, if you remember. So here, as x goes up by as x goes up by 5, we have to see if we kind of have a constant rate of change happening with our y values. So here, y went up by 4, and then it went up by 3. So this would be nonlinear because no constant rate of change. Okay. And then 8, remember our equations need to be in the form y equals mx plus b. Okay, so if we look at this one, if we distribute our x, we're going to end up with y equals 2x minus x squared, because x times x is x squared. Well, is that in the form y equals mx plus b? No, so it's nonlinear. Not in the form y equals mx plus b is your explanation. So you need to know what a linear function would look like. Okay, then we talked about discrete and continuous. We did go ahead and skip 9 and 10, but it doesn't hurt to at least know what discrete and continuous mean. Make sure you understand those things. If you actually did do these, this would be continuous because the depth in something could be half or 3/4. Hats you can't have a half or 3/4, so this would be discrete. But you need to be able to plug in and solve for functions as well. So on number 11, w of x equals negative 2x plus 7. Find the value of x for which w of x equals negative 3. If w of x equals negative 3, remember w of x is like this, is like y. We just give it a different name. We have our function notation there. So we're going to plug in negative 3 where we see w of x. And we're going to solve for our x value. So I'm going to subtract 7. Get negative 10 equals negative 2x. Divide by negative 2. And 5 equals x. Simple as that. Continuing on then. Now it wants us to graph. So I didn't put a graph on here. I probably should have. But I'll make a nice little graph here for each one. And you're going to need an XY chart. Okay, so for the first one, we're going to start with our XY chart. Okay. I would stick with right around 3 to 5 numbers. For time's sake, I'm going to go with 3. I'm going to go with 0, 1, 2, just to be easy. And then I'm going to plug them into the function. So 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. So these are my ordered pairs. 0, 3, 1, 4, and 2, 5. So my line looks something like, obviously the more points you have, the better or more accurate your line is going to be. So if you did 5 points, great. If you only did 3, that's okay for now. But you need at least 2 to make a graph. when we were working on Friday, we did 5, so it doesn't hurt to have those 5. Just for time's sake of the video, I'm going to make it 3 today. Plug this in. We have -3 times 0 minus 1 would give us -1. -3 times 1 minus 1 would give us -4. And -3 times 2 minus 1 would give us -7. So 0, -1. We're going to have to see if we can get this in here. 1, -4. 1, 2, 3, 4. And 2. And replace that one. 2, -7. So 1, 2, 3, 4, 5, 6, 7. Looks something like, ignore my line here, that. Okay, and then the last one, so what we can do here, 0 would be 2/3 times 0, which is 0. 1 would be 2/3, because 1 times 2/3 is 2/3. And 2 would be 4/3, or 1 1/3. So if you graph that, it's going to be kind of small. 0, 0, 1 2/3, 2 and something close to that. It's not very accurate on my made up graph here. That looks something close to that. So you do need those XY charts, and then do your best to graph. If you did that on graph paper, it probably helps. Okay, I believe we skipped $15. So if we just jump to 16, it says the function d of x equals 1,375 minus 110x represents the distance in miles a high-speed train is from its destination after x hours. A says how far is the train from its destination after 8 hours. So x says the hours, so we're going to plug in 8 for x. Eight times 110, 880, and then 1375 minus 880. Borrow there. 13 minus 8 will give us 9. 495 miles from its destination. Okay, because how long does the train travel before reaching its destination? So we have to think about where, if the train was at its destination, how many miles would it be from its destination? Well, it would be 0. So we would want to call d of x, the distance from the destination, 0. So we're going to plug in 0 right here. And we're going to solve for x, because that's going to tell us the time that we would be away. So we're going to figure this out here. Divide by -110. I subtracted 1,375 at first. And then we need to do some math. So if we plug that into a calculator, we would get 12.5. So 12.5 hours, and we would be at our destination. All right. If you have questions, you need to come see me Tuesday before the quiz, which means probably in the morning would be a good time. Have your parents write your pass. We can talk about whatever, but these are the types of items you would need to know. You can now go on to quizzes and try a few things. The 2 quizzes that I have available for you to kind of practice. Make sure you write them down if you don't have time in class to do them. But otherwise, just be prepared for the quiz tomorrow. Have a great day.